should we start?
And then you just turn. No, we want you in the middle.
Oh, really?
We
Okay.
do. And then you're going to just put
Turn
it
on.
on when it's
Okay.
your turn to talk.
Sure. Okay.
Okay.
Yeah.
And then any one of the reserved ones over there is good for you.
All right. So do I?
And any seat right over there. Yeah.
Ready? Okay. Should I start? Okay. Good evening. Please be seated. Welcome to tonight's program, Internet of Things. What is all the buzz about? I'm director of Caddy2, which is two division between the effort between Irvine and San Diego, with a major research and development focus on information and communication technology, but also explore their use for four things: healthcare, energy, environments, and cultures. So this has been the major efforts in Caddy2 in the last 15 years. So this is really the right timing to show you what this IoT is about. And before we start the program, I would also like to make an announcement of the new Caddy2 monthly seminar series on IoT. So we will invite the speaker probably once a month and to talk about either application side, thing is about application, I is about innovating the technology, O is about unify to have good handshake between application and technology. So we will have that seminar series for you. In addition to that, we will have the so-called the IoT from AM to PM events. What does that mean? From atom and material all the way to product and markets, so from AM to PM. And that will be the quarterly events. We will work closely with the professional society as well as the community to bring people together to really promote this IoT in Orange County in Southern California. This is what we will do. And at this time, I'd like to thank tonight's distinguished speaker for their contribution to make a successful events. And also the thanks go to the long-term sponsor, Kenobi, Martin, Olson, and Bear, for their long-lasting support. Without their support, I don't think tonight's event is possible. And also I'd like to thank the audience for your participation. I know now is the time to go home to be with your family to have a great dinner. But I think as you are so passionate about the IoT, I'd like to thank you. Be engaging and asking the question with our speakers. And after that, we do have network events and receptions, and we have prepared the dinner for you. So enjoy the good meal after long discussion in IoT. Lastly, I'd like to invite Michael Giuliani to turn over the rest of the evening to our moderator, Mike.
Good evening, everyone. As GP said, my name is Mike Giuliana. I'm one of the partners of the law firm Kenobi, Martins, Olson & Bear. We've been sponsoring this series of events, the Igniting Technology series, for, I think this is probably the 14th event. Okay, thanks. So, the Internet of Things. You know, when we talk about the way the Internet has changed our lives, the older people get a little nostalgic, so I want to get that out of the way. So, what was the world like before the Internet of Things? Early 1970s, generally people had rotary telephones. Bulletin boards were the things you used with thumbtacks. They weren't electronic. Calculators, about the highest tech piece of equipment you had in your house, maybe besides your TV, and maybe they were analog calculators. Mid-1970s, video phones, handheld video phones, only existed in science fiction on TV. The show Space 1999, and that's what they looked like. But it was a fantasy at the time. And just as another data point, in the late 80s, when I started here at UC Irvine, my first year, 1 megabyte of RAM was $50, and I had to ask my parents really nicely to get an extra megabyte of RAM for my 386, my PC. And if you look at the Fry's website today, 4 gigabytes is about $50. So when memory has dropped it's 4,000 times cheaper, right? That's, to put some of this into perspective. Before the Internet of Things, we had this saying, the whole world in your hand, and we only meant it figuratively. And once in a while, if something was in your hand, it was because you could pick up the phone and call somebody, and that's what it meant. But now, literally, the world is in your hand, and not only has it gotten into your hand, almost every kind of technology you can think of, it's now moved past your hand. We're wearing them, and it's in our eyeglasses, it's in our clothing, we wear them, we carry them, they're everywhere. So, nostalgia aside, I always, whenever I moderate these discussions, I like to give a little bit of advice in the world of IP, and it's generally geared to people who still find intellectual property mysterious or don't quite get what the whole point is or how to manage it. And so there's a couple of points I'll make for you quickly. To bring it down to 2 major points with regard to developing an IP portfolio in the IoT age. When you got to have a reasonable budget. You got to have a reasonable expectation of how much you need to spend. So you should look at the norms that are in the IoT space or whatever space you're looking at. And secondly, you have to understand how to apportion that budget. So I'll give you some examples. With regard to intellectual property protection in a lot of industries, including IoT, there is this 1% ballpark figure that proves out to be roughly true of how much you should spend on your IP. And I'll just give you some examples. Here's a success story. 2007, Google buys a company called Postini for $650 million. Postini had 30 patents at that time. If you rough guessed that each patent was $50,000, which is high, but you're including all of the costs, the internal costs, the patents that weren't filed because they were ruled out. They spent about $1.5 million, which is about 0.2% of that valuation of $650 million. Now, the Postini deal did include an entire department of people, included a brand, and it had a revenue stream, so it wasn't just IP. But you can see this 1% ballpark was in the ballpark. It's 0.2%. And there's a failure here. I think this is a pretty clear failure. In 2011, a company called SyncDocs came out with a product for making Google Docs work easier. They have 0 patents, but they won lots of awards and lots of praise. In 2012, Google Drive basically copied all their functionality, and SyncDocs is almost defunct. All of the blogs and the comments you see on their website are from 2011, and there's basically no new discussion about the company, and I don't know how long they'll even last because Google Docs offers the same features for free. 2013, Google buys Motorola Mobility for $12.5 billion. They had 3,800 patents. It roughly comes out to 0.9% of that valuation, the cost of their IP. 2013, Microsoft licenses Nokia's patents for $2.1 billion for 10 years. Nokia had 58,000 patents at that time. You could estimate their costs at about $1.74 billion, which is significantly less than the price of this license. It was only 10 years, though. So Nokia gets all those patent rights back, and Nokia got a lot of other revenue from that portfolio as well. So these are just some examples, and we have a table, a spreadsheet now of about 30 published deals that actually show that this 1% ballpark budget roughly plays out. It plays out in the success stories, it plays out in smaller deals and bigger deals, but that's just a rough guesstimation to have a reasonable expectation of what you should expect to pay. It's not a crystal ball to tell. There's no crystal ball to tell you exactly how much you have to spend to achieve the goals that you have. That takes a more in-depth, specific analysis. Moving on to how you should apportion an IP budget. one of the easiest ways to make a rational explanation that everyone can understand is to make your apportionment proportional to revenue. In other words, identify in your company what are the products or services that drive revenue, why, where, and when. And when you do that, you can then make a rational decision on how to apportion and prioritize your IP budget. Here's an example, a graphical example of how you might do it on a whiteboard. I tend to start by putting a dollar sign in the middle of the screen and thinking about your products and your services. Try to list on the board what are your present revenue drivers, what are the revenue drivers in the imminent future, what are farther off in the future, what's the next big thing, and look for commonalities across the page. And if you see some common elements that go from left to right, you know those should be higher priority because they will last longer and those investments will pay off longer and be relevant. I also put costs up here and profits, so that creates a rough picture of cash flow. And that's really important for making these decisions. So as a practical tip, I would do this kind of exercise on a periodic basis, maybe at least once a year with your officers, the technical people, the business people, map out your revenue drivers, and try to get consensus. And sometimes it's hard. The technical people and the business people sometimes have a hard time agreeing on these topics, but the conversation helps. And when everyone feels that they're on the same page, things run better. So I'll stop there and just remind everybody that what will happen next is all of our speakers will come up one at a time. They'll introduce themselves. They'll present their projects. And then at the very end, they will all come up to this table for a Q&A session. So we're going to ask you to hold all questions until the end. And so what I will do is I'll walk around with this microphone and do a Phil Donahue impression. And half of you don't understand what I'm talking about because you're too young. But just as we go through, I'll walk around the microphone. There'll be another microphone walking around. Just raise your hand and catch my eye, and I'll come over to you as one question's being answered. And we'll just keep trying to keep things moving along. So without anything further, please give a big hand to our first speaker. Oh, clap, please clap for the first speaker. Mark Bachman.
Okay, thank you for the clapping. All right. So we're introducing ourselves. So my name is Mark Bachman. I'm faculty here at UCI in electrical engineering and computer science and also in biomedical engineering. But mostly, I recently got this title, Cal IT2 Evangelist. So I'm going to stick with that title because I think it's very appropriate because my main job at Cal IT2 is to instigate and promote and educate people in what Cal IT2 does here, and what we do here is IoT. For the last 10 years, Cal IT2 didn't really have a name for what it did. We did sensors, we did internet, we did big data, all these different things. But just recently, this term IoT, which is actually an old term, but it's now become popular, it just sums up so nicely what we do at Cal IT2. So that's my job. All right, so I'm going to talk to you about the Internet of Things. I'm the lead-off speaker, so I'm going to give you an overview of what IoT is all about, and then we get into some of the details of different markets and different applications and technologies and so forth. So let me give you the big picture on what we're talking about. All right, so 3 major things have happened in the last few years, and to me, these are the main drivers for IoT. The first thing that's happened is we've had extreme miniaturization and commoditization of electronics. Basically, electronics is super cheap. Everybody has access to the same technology, and so it's now a commodity. Second thing that's happened is we now have global telecommunications infrastructure. Pretty much everywhere in the world we have access to cell phone towers. We have internet almost everywhere. So now we have the ability to connect to everywhere in the world relatively cheaply and easily. And finally, we have a generation. We have the millennials coming online. And this generation grew up with technology. We're just talking about how us old folks, we grew up with rotary phones and things like that. And, you know, it's like it's this new gee whiz thing, and we're all worried about technology, but our kids don't care. They grew up with it. And these guys are in their 20s and 30s. They grew up with technology, so they have massive acceptance of technology in the marketplace. Those are three sort of magic ingredients that create this sort of movement we're seeing that we call the Internet of Things. And this is actually going to have huge impact. I'm going to talk a little bit about that. Okay, so you can see electronics. This is Moore's Law. You see basically electronics gets cheaper every 18 months, and the number of transistors on a chip increases exponentially. So this is old news to anyone who knows technology. We've been doing this for a long time. It's phenomenal that you can double your transistors or half the price of a product every 18 months. That's really phenomenal. But we're seeing the same thing actually in internet too. The number of connections on the internet is also rising at an exponential rate. So we could have sort of a Moore's law of the internet, and it would be true. We're seeing the same rapid rise in connectivity on the internet. And as I said, we've got a generation now that's comfortable with technology. Even us old folks are comfortable with technology. We're on Facebook. Our kids hate it that we're on Facebook, but we're there too. So we're, the whole marketplace is now ready for something called the Internet of Things. All right, so what happens when everything gets smart and connected? Well, you've probably heard in the news a number of different projections and so forth. They're all phenomenal, these projections. I'll just quote some of them for you. By 2020, we're expected to have over 50 billion devices on the internet. Okay, just do the math. That's 6 years away. Divide by 12. How many things have to get manufactured every month to support that number? It's about 650 million things a month. Okay, so that's a huge opportunity in manufacturing. Okay, for those companies that are already in this space, they're claiming triple-digit growth in all their market sectors. In energy, transportation, digital cities, healthcare, financial services, and retail. This is Verizon's report. Triple-digit growth. Actually, that's not completely true. Healthcare is only double-digit growth. It's not triple-digit growth because healthcare always lags behind. But it's high. It's like 60%, not 120%, but it's still a very high growth rate. So we're seeing this amazing growth in those companies that are already doing this. You may be familiar with this very famous quote that came out in January, or was it February at CES? $19 trillion market by 2020. Okay, that's a phenomenal number. The U.S. GNP is only 16 trillion. Okay, that's bigger than America. Okay, that's a huge number. Okay, and we're expecting a lot of winners in this: semiconductor, network guys, sensor guys, big data guys, and so forth. To me, this is the makings of a revolution. This is not just a new market that's opened up. This is a revolution, and I want you to think of this as a revolution. Many of us have been through this before. .com was a revolution. It just completely changed everything, okay? Well, this is like .com all over again, but it's going to be bigger, okay? So for me, when people ask me, I say, look, there's really only two numbers you need to know. The first number is a trillion, because every estimate that I've read, every single estimate, the numbers are measured in trillions for the market. And the next number is 6 years to that, okay? That's a huge amount of growth. No matter how you can argue about the details, it's still big numbers no matter how you get through this, okay? All right, let me give you an example of an IoT application. So what's this all about, okay? Let me use retail as an example, okay? So here's Target, here's where we go shopping, and you see, when you go to Target, it's relatively boring. You go in these aisles, and there's all the food on the shelves, and they're sort of presented to you, and our job is to go and select the items that we want, okay? That's sort of the current model of retail. And retail is very expensive, right? You got to pay for warehousing all this stuff, and you've got to maintain air conditioning and brick and mortar and leasing and so forth. Okay, and you know that brick and mortar is getting its butt kicked by online. Okay, online retail is really hurting traditional retail right now, because when you go to Amazon, you can comparison shop, you can find all kinds of details, and of course, Amazon tracks every mouse click you make, right? So Amazon knows what you want. Amazon can offer you suggestions. It can give you coupons and so forth, okay? Hard to do that in brick and mortar, okay? So what do we have? We have the shutting down of major retail brands, okay, such as Best Buy. In 2013, last year, retail outlets experienced half foot traffic from 3 years earlier. I hope that 3 means I have 3 more minutes. Oh my gosh, okay, let's go. So what can brick and mortar offer that retail cannot? Okay, that the online cannot. Brick and mortar can offer an experience, a physical experience, okay? You don't get an experience when you go to Amazon. When you go into a nice place like this, you get an experience, okay? And that's what brick and mortar can offer, okay? It can offer a place where you want to be, okay? It can offer unique things that you cannot get online. But how's it going to do that, okay? It's going to use the Internet of Things, okay? We're going to use sensors, we're going to controllers, we're going to use big data to understand what people want, what are their patterns, and how can we best deliver to them an experience that is valuable to them, okay? And so I'm going to skip over this because I don't have much time, but there's a lot of activity that needs to go on, all the way from the physical connected devices, all the way to the analytics, application platforms, and integration with existing systems. That's opportunity for many, many people to bring value to a place like Target or Best Buy, okay? I give this lecture to my students, and I want to always be mindful that when we enter a revolution, there's unintended consequences. We can talk about that. I don't have time to talk about that, but we are definitely going to be seeing some things that are not so good. We recognize that. So we need to be aware as we move forward of the challenges we're going to face as we instrument everything, okay? This is a report from The Economist. These are companies in Europe and the United States. 0 means the company doesn't care about IoT. 10 means the company is fully engaged in IoT. These are averages of hundreds of companies based on interviews with C-level executives. And in Europe and America, we're about the same. Every company is about 4. That means they just are leaving research and they're getting ready to implement. The timing could not be better, okay? This is from last year, 2013. To me, this says, as these companies want to move up into IoT, this is the sweet spot. This is where we need to get in now and offer them the products and services that they need, okay? There's a lot of ways in, depending on what you like to do. Down at the bottom of the food chain, we've got the sensors, we've got the effectors, we've got the embedded systems, controllers, we've got the routers and the communication devices, we've got the servers, the hard drives, we've got the telecommunication services, cloud services, security, web applications, analytics, big data. But the top of the food chain is what are you going to do with all this? You're going to produce an application that brings value to somebody, right? This is on the front end, because that's my specialty, the front end. We build our physical interface modules, we connect them to modes, we route those through servers onto the cloud, and then we do the cloud services to figure out what that means and how that can be used to bring value to a customer. Okay, I'm going to skip through all of this. This is sort of an education on all the parts and technology, but I'll be happy to talk to you afterwards if you have questions about what do I need to build to be on IoT, you know, what kind of product should I invest in, and so forth. There's a lot, okay? And what we're seeing eventually is the connected world, right? Everything is connected, and that data is meaningful, okay? We're going to generate, you know, exabytes of data, that's for sure, but that data is useless unless it's meaningful and can bring value to people. So that's the goal for the Internet of Things, end-to-end integration. All right, now I just want to plug Cal IT too, because I am the evangelist for Cal IT too, right? This is a great place for IoT. We've been doing it for over 10 years, okay? Everywhere from the basic technologies where we developed custom sensors, embedded systems, architectures, big data, analytics. We have some of the best people in the world here working on those kinds of problems, as well as applications in healthcare, applications in energy, applications in culture, applications in environment. And we study this too. We work with our think tanks on campus for security, privacy, trends, and markets, okay? 2 examples. Professor Lee asked me to give you 2 examples. The first example is from healthcare. So here's the grandma of the future. The demographics have changed. Our seniors now are more willing to get involved in technology. We're going to use technology to help people stay healthy, and we're going to bring that information to the internet. For example, in this exergaming system here, where we can now connect video games to exercise machines, put that on the web, and now we can analyze that data to understand how best to keep someone on a healthy regimen. In this case, it's an example of a company that used that same concept to bring rehabilitation technology to people, and that data is shared with the physical therapists to make a very good regimen. They're actually doing quite well. This is their company now. And outside we have a booth that shows one of the technologies we developed for healthcare, because we want to bring all these technologies in the home. It's a super simple way to get things on the web. We call it Wendy, Web-Enabled Devices Interface. I encourage you to talk to the students outside. They'll show you all kinds of cool ways to do it. Basically, we decided to keep it simple for everybody. We turn every single sensor into a web page. And guess what? Over this. Anyone, web apps can be written by anyone, from 13-year-olds up to 30-year-olds. The rest of us, we have to go ask our kids to help us with the web apps. Okay. All right, so to wrap it up, I claim there's a storm coming, okay? Everything is right for this storm, okay? All the conditions have come together at the right time, okay? And it's going to rain money, okay? For sure, okay? That's what I tell people. So they'll hire me to consult with them. But I can't tell you where to put your bucket. See, that's the problem, okay? I can't tell you where to put your bucket, okay? So this is actually a scary picture, isn't it, right? It's kind of dark and scary. I shouldn't use this picture. In California, actually, we love storms. You know why? We get great waves, okay? So just think of this as a wave. Are you going to be on the side watching, or are you going to be right here, like this guy here? Okay? So that's my question to you. Okay, thank you.
Can you hear me?
Yeah.
All right, so my name is Matthew Cheng, and I'm Senior Technical Director in the Broadcom CTO office, and so I'm here to share the view of, at least from myself, in the past few months I've been focusing on the, I use the term M2M here because I think the IoT has been overused. Actually, all these acronyms has been overused anyway. But I kind of like the M2M because myself, I was in cellular development before. So every time when I see the word IoT, I think it's interoperability test. So, but anyway, so we're talking about the same thing. So I'm not in the wrong meeting here. So, let me move to the next one. So what is IoT or M2M? And this is a quote from a book. And you look at it, basically I think a lot of things. So we're talking about, there's 10 billion people by year 2020. And then if assuming that each human will be served by more than one computer and all these things. So we have computers in the car, can be for for health or purpose. You can all have all the computers for health purpose, and so forth. And all this you get to something like 1,000 billion computers are in the internet by 2020. So I think you probably noticed there's no word for like IoT or smart, or it's still the old word computer. That's kind of like the grandfather word for computer. So this is the book. The New Internet Protocol by Christian Hiltermann. So actually, Christian was an old colleague with myself in the Bellcore when I started my career in the industry back in the mid-90s. So you can see that that's mid-90s. So we already, at that time, almost 20 years ago, at that time, people already have the vision of all these different things. Or at that time, we call it computer, but connect together. So I think kind of now it's 1,000 billion, but I think the previous speaker already talked about 50 billion. That's just a number, but it's a huge number of things. So I think, to make it simple, is a lot of people, I think, again, there's another word I hate is smart. So now everything is smart. Even Bluetooth LE is renamed to Bluetooth Smart. So what is considered here, I see it, anything that's smart, meaning you have a microprocessor in it with some software running on it and with some form of connectivity. So that's how I see things. So that's the key thing, right? So that's something you can program, and the connectivity is another key thing. So that a standalone computer would not, we're not interested in that. Something that need to be connected to the rest of the world. I think I probably skipped the marketing stuff because I think already there's a lot of numbers get presented already, but basically huge number. There's some number actually now from Cisco. I think they're claiming, I think 14.4. I think earlier in Mark's slides of 17 trillion already now. Actually from the industrial Internet Consortium, that's GE and IBM, others. I saw a number something like $32 trillion. So it's like that number keep increasing actually every time you checked. But anyway, so a lot of opportunities there. Okay, so the vision exists already, back in the 90s, right, mid-90s. Why, suddenly becomes hot now, right? Why we didn't have that? So if you look at it as mainly, I think Mark also and Michael mentioned that earlier. Of course, we have a tremendous improvement in silicon, right? In terms of the silicon just get faster and cheaper and lower power. So these are the key things, and then same thing for the memory and all the other things. The next enabler is wireless connectivity. So I think back in the mid-90s, I don't think everyone, I think there might be someone using a cell phone. At that time, it's not called smartphone, it's called cell phone. Right? And not that many people use it. Actually, I had one back then, and I basically turned it off all the time, and just for emergency purpose, I put it in my car. But these days different, and of course the cellular side of it help a lot. I mean, the GSM standard that allows the global, basically global cellular standards that allows the phones that you can basically travel around the world and still work. That's important. And then that's on the cellular side. There's a bunch of acronyms here. I assume if you don't know about these things, we can talk offline. But basically from the so-called 2G to 3G to now the latest one's the 4G. Technology, they're still trying to figure out what exactly 5G will be. So no one knows what the 5G will be for the cellular world. And then on the, so that's more the wide area. Then for the short range or the local area, personal area side, we have the Wi-Fi. AO2.11 wasn't available back then in the 90s. But then once the AO2.11 becomes available, and that's another explosion there. And then I think pretty much these days, every phone, every smartphone has a Wi-Fi, and then a lot of people has Wi-Fi, access point in their home, and then in Starbucks and in airport, all these different places, and of course the Bluetooth, and that a lot of accessory using that technology. And that comes to the devices, the explosion in the mobile devices. So back, as I mentioned, back in the 90s. Of course, the cell phone penetration was not that high, but these days, the cell phone penetration is already in some country already over 100%. So that's actually the number of phones more than the number of people in that country. And I think a lot of you probably, not just yourself, but myself, I have 2 cell phones myself. And then my wife have one, and then my kid doesn't have one yet because my kid's only 10 months old yet. But then actually it's interesting, I don't know why, but he's very interested in my cell phone. So maybe because I use it to take a picture of him, so now every time he wants to get hold of my cell phone and play with it. So all these things, and then of course the sensors, and that's another key enabler in the IoT. There's a lot of chip sensors out there, to monitor your heart rates, monitor the humidity, monitor all kinds of different things, and all this at the low cost. And the cloud, and I'll put some of the famous names here, and definitely, whatever the IoT is not something new. We're not going to reinvent, the internet and say, Web 3.0 and things like that, right? So people already call, say, Web 2.0. We already have a bunch of, all this company already have a bunch of services and APIs, and there's a lot of applications already developed there. So the IoT, what we are talking about is adding a lot of other things. So in terms of the traditional, now we have smartphones, tablets, and TVs now connected to the internet. There will be a lot more other things connected to the internet, but those things are not living on their own cloud service, but somehow hooked up to, say, for example, there may be something, some things you can think about to monitor certain things, and then you can, once you, actually it's a kind of a interesting thing, is that's from an open source project, and someone make a fart sensor. So that's basically an embedded device. You can actually put it on your chair, and then every time you fart, then they will post post something on the Twitter. So I don't know, but that's an open source project doing that. So you can do all kinds of things there. So I think I'm running out of time. I think I'm going to skip that to. So this one, I'm just showing. Again, I'm not going to go over the details here. So what's the problem of the IoT today? The problem of IoT today is too many alphabets. And if I think for people long enough that you probably know, back then, say LAN, back in the late 90s and so forth, that's the same thing. So I don't know how many people still remember Token Ring, ISDN, ATM, not the cash machine, but the ATM as a networking technology. But then, over the, that's because at that time, the first version of internet basically, take off, and all this different innovation. Then, of course, ultimately, the market decide, certain technology win out in the race. So now you can see that I think IoT, Mark's slides already say, in some of the survey, we are basically a lot of companies is in the planning phase. So you look at from the technology perspective, there's so many different things there. A lot of things like you can see, CoAP, or MQTT, and or XMPP. XMPP actually originally that's for Google Talk, and they're even trying to modify it for things. So that the explosion of all these different technologies and standards, just telling you, this is now really hot. This IoT. What I'm thinking is, of course, I think eventually there will be some consolidation. And what would that be? Something that at least end-to-end. So basically, IoT is, as I said earlier, it cannot be just a standalone, some kind of a smart device connected to the internet, but you really offer a special user experience end-to-end, and not just within the home or within a factory or within the an enterprise environment, but basically it's something that you can access these things not just when you are in that environment, but also anywhere in the cloud. That's at least my view. This end-to-end to have everything hooked up together. So that's my last slide. So this is another thing that critical in the IoT is really low cost. I call it open device platform. So open source software is not new. I think we had open source software for many years. But open hardware is not that long history. So you can see, like, for example, Raspberry Pi. Raspberry Pi actually, it's only $20. They have several versions, but the latest version, they come out only $20. And you can build $20 and actually, one of the goal when Raspberry Pi was set up is to have low-cost computer. So you can actually, instead of buying, $1,000, so $1,000 iPad, and you can actually, buy a $20 Raspberry Pi for your kids to play with. So if they break it, then it doesn't break your bank. So I think this is another key thing that enables a lot of innovations from not just the big companies, but basically anyone, students or anyone in their garage, they can do this and then come up with new ideas. Okay, so I think that's all my time, and I'll hand it to my next speaker.
All right, hold on, let me get the show started. All right, hopefully everybody can hear me. I'm not sure if this, you hear me now. All right, hi, I'm Art Hitomi. I'm CTO of a company called Nemescent. And first of all, thank you, Cal IT2, for inviting me. One of the things about Nemescent is that it came out of UC Irvine. So I'm very happy to be representing this. Actually, quite an impressive panel here. So Numescent basically came out of the PhD research that I was doing over at the basically the ISR group, the software engineering group. And I was very lucky to be working with a great bunch of people. My office mate wrote the HTTP 1.1 spec. The WebDAV protocol came out of it. There's this API called REST. I don't know if some of you have heard of that. That also came out of a dissertation. So being on the ground floor of the web building up was not only an amazing experience, but I actually see a bit of flash with IoT, which is why I'm very excited about IoT. A couple other things too. I think as Mike has mentioned, some of the IPs and how important it is, but also too, there's been a lot of other technologies that's been developed. Like early on, one of my other coworkers had put together a satellite and launched a satellite and created a peer-to-peer network right in the sky. This is late 90s, early mid-90s, late 90s. And one of the things that's interesting is, there's been a lot of IoT-like things that's been done in the past, and I'm sure there's some of you who've been around for a while agree that, maybe it was just too early at its time, it hasn't taken off. But the other thing, too, is quite interestingly, too, those patents are expiring. So to some extent, right, you have a new opportunity there for old ideas that may have been too early in time now being something that you can productize. So that's something definitely is, I would call, green fields for people in this market. So with regards to Numescent, so that's a little bit of background in terms of how the company was formed. And I want to talk a little bit more about IoT. And what's interesting is that the cloud today, and I know we didn't talk about 1.0, 2.0, but I'm going to talk about 1.0, which is today. And you'll notice that we have everything here, right? I find the kitchen sink interesting, but refrigerator too. But everything's going to be has this notion of connected. But what's also odd about this model is, just notice about the cloud, AWS, and everything. Everything is done in the cloud, right? A lot of focus is on processing completely on the internet, and much of these devices just becoming endpoint peripherals, right? So a lot of times when you talk about even the virtual desktop, all the desktop is being executed somewhere on some cloud, but all you're really getting is a screen scrape, that's coming down. And I think what's happened is that the cloud is powerful, connectivity is great, but is it really going to scale? And I think with IoT and the movement of devices, what you're going to have really ultimately the next phase is a real mesh. And I truly fundamentally believe this is very, very important, is in order to scale your applications, your devices, whatever that might be, you're going to have to make the system a bit more distributed. What's also very interesting too is that you look at all these devices, the iPhones, they're not getting dumber, they're actually getting smarter, and for a very good reason. And it's because people are demanding that more is done locally, right? Not everything should be done in the cloud, and there's an important reason for that. It really has to do, again, with scale. So speaking of that, there's obviously, when you go ahead and, this world of IoT and these world of killer apps come for these things, there's going to be all these challenges. Certainly, with my presenter before, talked a lot about the hardware challenges, but certainly there's going to be a lot of those application challenges. The integration is certainly one the standards bodies are hopefully addressing, but obviously, if you can't have, one device talk to another or to another cloud, then, the value of that isn't all that great. Security is an interesting one because, in one sense, this is a hot topic in IoT, right? If you're a pacemaker, right, you don't want somebody hacking into that. But at the same time, if we live in a world where we're not sharing, I really honestly feel that, to some extent, you're limiting the applications IoT. So, I think one of the opportunities for IoT is certainly looking beyond, just having, a device be, like your garage door opener talking to your phone. I think ideally, if that information can be shared across other people and really make things open, I think this is where, you're going to see, these kind of killer apps. In the case of Facebook or any of these latest internet applications, or Mint, for example, they grew because, they kind of challenged, I suppose, society, right? My bank statements, it has to be completely, it's all private. Well, but, maybe, having some information to advertisers is valuable, right? Maybe it will better your shopping experience. So I think these are things that even though with IoT, a lot of focus is being placed on whether or not, you should completely hide your data and all these personal things. I think hopefully society changes and kind of goes with the flow. And then I think with the new people, the younger generation who will take pictures of anything, I think these people are going to be far more open. There's going to be great applications out, that can be had. And hopefully, will benefit society as a whole. So what is it that Numescent is doing in this space? Well, Numescent right now is doing really more for the data center, the delivery of applications. And where this fits in IT, I will explain. So right now, you have an application, such as Photoshop or Trackmania. It turns out when you go ahead and get these applications, you don't need the entire application to run it. In fact, this is a histogram of what parts of the application is actually required to run. I have a video, but I'll save time by not playing it. But what you can see is that in order to basically run Photoshop, do you really need all the spell checking features? Do you need all those other things? So what Numescent is out to do is to basically improve application updates, right? In the IoT world of things, we predict that everything's going to have software, right? Software is going to be critical because things will be needed updated for interoperability. Things, specifications need to be updated. So is there a very quick way of basically getting those kinds of information, right? Getting an operating system update, or even getting whole new applications to these devices. So we just figure out a way of optimizing that delivery. And in fact, if you can imagine if you're going to run something like Microsoft Word or PowerPoint on your machine, if you ever look at Task Manager, you notice that when it launches, it's about 80 megabytes, right? Well, why download that whole install of PowerPoint to run it? Why not just run what's in that physical memory? That's in essence is what Numescent does, is figuring out what that is, and then virtualizing the environment and then delivering the rest of the pieces on demand. So that's one of the things. And as you know, with the IoT, what we hope to do is we hope to deliver these kinds of content, whether it's a whole operating system, whether it's an application, and efficiently just get it to the systems update. Because if you're talking about orders of magnitude more connected devices, right, it's going to be hard, especially if these devices don't have much power, they're intermittently connected, they don't have very good throughput. You're going to want to save every bit of power, every bit of bandwidth you can get. And also, another important part is I think aspects of P2P will also come back, right? Because in order to build these mesh grid networks, you're going to want to not go necessarily all the way to cloud. If you've got another smartphone device that's next to you that can basically provide that information, then why not use it? In fact, you see a movement for Nest, all these home devices becoming a gateway, for these, let's say, less able devices. And I think that's another pattern of IoT that you'll be hearing a lot about. So I think that's really about it. The Numescent as a company, we've been doing this on the, certainly on the more the desktop side of things, delivering those things, making things automated, and we've proven it to a lot of people. In fact, what's interesting is that, it's for the delivery of these large applications, it turns out that even the data center, large efficiencies can be had if you can really tune things in. So to end my presentation, one of the nice things that I learned from my colleagues is, with working with the IETF is that, there's John Paso, passed away many years ago, said basically be conservative in terms of what you send, liberal in terms of what you receive. And I really hope that when you go to design whatever killer app that you guys have, that you do follow those principles because the scale and those issues would really come to play when you go to practice. Thank you.
Okay, good evening. It's a pleasure to be here with you this evening. I'm Sean Kirby, and I lead a group at Cisco in our consulting services organization that creates rapid prototypes of novel business solutions that we think have the potential to change our customers' business across a variety of industries. And we're very excited about the possibilities of IoT. In fact, we're so excited that we've actually created a new acronym for it because we believe there are some additional components that will add even more value to this wave that we're poised to ride. So we call this the Internet of Everything, and the additional components are the data, the process, and the people. So the data and associated analytics technologies to be able to derive new insights and to make predictions that we can use to take intelligent action. And then the process to re-engineer how business is done and to lead the change so that organizations can really take advantage of these technologies. And then also, of course, the people. There are a number of stakeholders, and in the end, that's what it's really about, is making life better for employees, business partners, consumers, whoever can be the benefits of this tremendous wave. So one example that will illustrate the importance of these different components is an area where we're seeing tremendous traction and some initial value captured from the IoT, and that's in the area of smart connected parking. This is a problem that I think people can identify with the world over. For example, the average Parisian spends up to 4 years of their life just looking for a parking space. So to solve this problem, we need not only to connect the devices like the parking space sensors, the meters, the mobile devices, et cetera, but we also need new analytics, new ways of processing that information so we can predict when a space is likely to free up or what the demand is likely to be in the future. And then, of course, we need new business processes, new models for accepting payment, new models for pricing, perhaps even dynamically. And then last but not least, there are a lot of people involved in this. Of course, the citizens who are doing the parking, but then the parking administrators, and of course, the whole city administration making use of all of this wealth of data to improve their city planning. And that's not the only example, of course, in what we call connected cities making use of this technology. We're seeing applications everywhere from smart energy to improve efficiency, to smart traffic, to reduce congestion, to every aspect that will improve the health, the safety, and the attractiveness of living, working, and playing and learning within the city. And that's not the only industry. In manufacturing, for example, we're seeing tremendous gains and improvement in everything from manufacturing efficiency to safety and beyond by instrumenting the machines that are doing the manufacturing with every type of sensor you can imagine, from pressure and temperature to torque and load. We can predict much more accurately now what the optimal maintenance routine will be for that device, and we can really push it to its limits to improve the throughput and efficiency and avoid unplanned outages, and also improve the quality of the manufactured product ultimately. We had one of our manufacturers tell us, in fact, that if we simply put Wi-Fi tags on some of their key tools, we can save the average worker up to 30 minutes a day that they spend just looking for their tools. So the economic value is really impressive. And in the opening introduction, I really appreciated the references around retail. This is also an industry that we're finding some very exciting applications. We're working with a number of large retailers to do some very exciting things to bring back the brick and mortar experience, to bring that back in life, to transform not only the experience but the operational efficiency. Some of the things we've done are to put sensors, Wi-Fi sensors on the carts so that we can track their paths around the store or the hand baskets. We can see what the typical paths are, where the shoppers are spending time, and so forth, and then what they're purchasing relative to that by fusing with the point of sale data. We can also position cameras strategically and then understand what's the flow of traffic into the store and how many people are in the produce section, or even look at the refrigeration doors opening and closing. And this is actually, we believe, a leading indicator of imminent demand for checkout. So we can send a cashier down to the checkout long before the lines ever even build up, or send a cashier out if they're going to be decreasing to serve the customers and keep the stock on the shelves. And for any one of the top 10 retailers globally, this is worth at least $100 million per year in operational savings, or as much as $1 to $3 billion a year in getting over the out-of-stock problem. But perhaps the most exciting part of this across industries, something I like to call the potential to really go down the last mile toward eliminating friction in business. We've seen revolutions in the past, like from the Industrial Revolution to e-commerce, and the tremendous leaps forward they've provided in terms of productivity and efficiency, but there are still some stubborn barriers that have remained to achieving complete frictionless business. Take fueling, for example. We drive up to the pump, spend some time looking for our credit card, maybe a rewards card as well, maybe even have to go inside and pay cash, worst of all. Then maybe entering your zip code on the device, selecting your grade of fuel, and all of this takes a lot of time. In fact, time and motion studies have shown that this could take up to a third of the full transaction time. So the IoT, of course, brings new capabilities to eliminate this last source of friction. Really, two of the key ones are confident identity, so being able to know who I am for sure without others being able to defraud that or to spoof me, and then knowing precisely where I am. And so precision location is a very important ingredient as well. When I have my vehicle, I need to know which pump to turn on, and with these capabilities, in the future, we should be able to just drive up to the pump, fuel our vehicle, and then drive away, no strings attached. So all of this, of course, adds up to a tremendous number. It's been cited a couple of times before. We've done some pretty detailed analysis. And the components of this are both public sector and private sector. And what's interesting as well about this is that only about 60% of this value, we believe, is new value creation. The other 40% is value at stake. And so this is poised to change hands. So the early adopters of IO, we think are going to be at tremendous advantage to the later adopters who actually may stand to lose in this new economy. Well, this is all great news, but there are many concerns, and we've had some of our other panelists as well talk about some of these. We completely agree. I'll just highlight a couple here for the sake of time this evening. Privacy is one of the chief concerns, and we believe essentially here the key to success is adopting a mentality of symbiosis. How can I make the information that I try and collect useful enough so that participants will be willing to provide it? Always be very open and transparent about what's being collected. Of course, security is very important, and our point of view on this is that you really can no longer define a constant and steady security perimeter. So you need a new architectural paradigm to be able to provide the security. Who knows what devices we may want to connect in the future, so you can't define a hard boundary. But if we have a network-based security that's able to control throughout the network and provide central policy control, this can really enable us to make devices both easy and secure to connect. And the last but not least, this is a new phenomenon I like to call the programmable world, and I think it's going to mean a tremendous change that organizations need to be aware of. Through a convergence of many things like devices becoming more programmable and programming tools becoming a lot more visual and intuitive, everyone now, even without a deep technical background, is going to be able to create these fantastic business solutions in the future. This is going to accelerate innovation dramatically, and organizations really need to reach out to a wider audience and be much more inclusive in their innovation programs. So these are just a few of the reasons that we're extremely excited about this new wave, and would like to invite you to think with us as we discuss throughout the rest of this evening. Imagine what the future could be like, eliminating these last barriers to truly frictionless business. Imagine, for example, a world without any shopping lines, without any blackouts, with minimum traffic congestion, or without spending what seems like an eternity to find a parking spot. We believe the future is very bright indeed. Thank you very much.
Okay. Good evening. My name is Alcho Parena, and Mark, I'd like to thank you for the analogy of the storm. I'm going to spend a couple of minutes on a commercial. It's free, so I need to pump up my company a little bit before I talk to you about the IoT. But I'd like to thank Mark, and hopefully we're putting the buckets in the right places. But so far it hasn't rained that much. So I like to talk about the practical side of IoT. We've been doing IoT without calling it that a number of years. And I'm going to take you through maybe 3 applications of where we have actually put it out there for the world to use. I founded this company a few years back in the field of home automation, and we've taken it through an evolution of sorts into where now we're focusing on smart energy, energy management, and the connected home. And it so happens that a few companies come to us with what we now call IoT, where they have a specific problem, and they basically trust us with coming up with a solution. So we are a provider of IoT and connected home total solutions, including cloud services, a hub that aggregates several devices, as well as devices themselves. We have a broad portfolio of these devices using technologies such as Zigbee, Insteon, Wi-Fi, and cellular, pretty much the cornerstones of what is used now to connect these objects. We have a unique industry position currently. We've been fortunate, again, as I mentioned earlier, to have been found by certain large companies. And to that end, we now provide connectivity products for electric vehicle charging. It's one of our largest segments and fastest growing areas. Also, a local set-top chipset manufacturer who is in the audience chose us also to power a new generation of chips for a connected home platform. And we also don't believe that the cloud's everything. And I believe in the model that cloud one, maybe we're trying to put everything in the cloud, but the reality is the cloud belongs where it belongs, and certain things, and I'll get into that a little later, when it comes to object, things can talk without a cloud service. What do we do? Again, the commercial part. We make, as I said, an end-to-end solution where we can supply a user interface, the basic approach or the basic window into the devices and that you're trying to control, allowing you to practically do anything that you need with the devices. The gateways or controllers and cloud services is what provides the connectivity for that ecosystem that you're putting together. So as I'll show you in the various architectures that are possible for IoT, we have these hubs or gateways that can provide a very unique aggregation service for these things and an abstraction of sorts to make devices look pretty much the same to the application. And of course, the ecosystem without which nothing would work, mainly divided into 2 worlds, the actuators and sensors. And we make a variety of these actuators and sensors for various things, such as lighting, doors, window sensors, appliances of all kinds in terms of providing an ability for the appliance to talk to a service, irrigation controllers, and so on. Now, how do we define IoT? And this is, again, after thinking about it over the years without even talking about IoT, we look at the world in terms of things, right? I like to call them objects. But we see IoT as the connectivity of those objects when we look at them as sensors and actuators. Again, just 2 classes of devices under an action-oriented framework. Sensors, without an action being taken upstream, they're really worthless. So we look at the world in terms of information and actuation. But so what? So what if we have this connectivity without a purpose? And we define that purpose as being able to help humans by operating a client-server relationship with a determined or learned degree of autonomy. So that's a mouthful there. So what I really mean is that the devices themselves, we don't want them to get carried away. We want them to learn, but not to become our masters. So we have to be aware of all of that in terms of the social impact that it could have in the future. So sensors, I mentioned to you, informants, actuators as actors. So this is what I think we need to know about the IoT component. And I define these basically as a quick information sheet on IoT. We have informants which are there to produce information such as time of day, temperature, humidity, light level, carbon dioxide levels, and so on. Actors are the ones doing the work. They do something with that information, such as opening or closing a contact, opening a drip irrigation valve, locking a door, dosing fertilization, and so on and so forth. Commands are the instructions to do something. So typically, devices respond to commands. Clients, now we're talking to client, the ability to have a client-server relationship. What I mean by that is the client is there to send commands. The server is there to receive the commands and hopefully do something with that command. In the past, we had technologies that we used to call them send and pray because you would send the command and you don't know where you were going. There are many variations of IoT, think-to-think, cloud-mediated things, and so on and so forth, and I'm sure you can add many, many more. It seems like I got to a 3-minute limit very quickly. So these things or these variations of IoT, you choose based on the degree of autonomy that you want to create and a lot of other factors. Now let me give you an example of 3 examples, if I have time, to show you some real application. We did this for the Department of Transportation in Delaware, where they have depots where the maintenance trucks come in. They plug them in at night into block heaters, whether it's going to get cold or not. So they start doing this in December, and they do it through February or so. And we simply provide them now with what we call a side controller. It's a cellular connected device, which is also has a Zigbee component to it, and a Zigbee load controller, as well as a temperature and humidity sensor. With that, they're able to use our cloud for connectivity and can access that from any point in the world. Very simple application, but it solves a huge problem for them. Another one, this happens to be a typical installation at the NRG Stadium in Houston, Reliance Stadium, where we are managing a Zigbee charger network, or a charger network based on Zigbee. So each charger is equipped with an RFID for authentication, a Zigbee controller, and then there's a side controller with a cellular modem that communicates with the NRG cloud. So this is a very simple application, but with huge impact, benefit to NRG. This is one where we have partially implemented what I call IoT in farming, where the objective is to minimize the overall energy use. In a farm, you have a lot of things that consume a lot of power, things to move water around, getting it out of a well, putting it into a reservoir, pressurizing it to go into the property, irrigating, and so on. So this is an example where we put our hub connected to the smart meter directly, so we can read the whole house consumption or the whole energy for the site. Using the cloud, we can then get all the information that we need and manage, orchestrate things like irrigation controllers and monitor the entire energy for the operation. We have several devices, but you can see some of that outside, so I won't spend too much time on them. Only on this Harmony Gateway, which happens to be our latest entry, is the size of an oversized pack of cards, and it runs on Android. It's a media server, but it has built-in Zigbee, so it can work as a gateway with all the power of that. So I call it our small size, big performance box. And I want to leave you with some tips in terms of IoT implementation. Understand what it is and what it isn't. I think today we've heard a lot of definitions, but importantly is to know how to use it. Like anything, define and visualize what you are after, define it carefully, make sure you have the right architecture, and then be willing to pilot, because things aren't going to work the first time. And realize that iteration is a factor of life. So with that, I stay on time. Thank you.
already can't read it. So good evening. My name is Miles Mahoney. I'm the general manager at Frost Data Capital. I'm responsible for our industrial data analytics practice. Today, in the 10 minutes I have, I'm going to talk about the industrial business aspects of what we're doing from an IoT perspective, the industrial internet. And I always say, you know, Al Gore didn't create the industrial internet. Maybe he claims he participated in it, but he doesn't get credit for it. I'm going to talk about why some of our big strategic partners, in particular today, GE, why they're so excited about it. And then the third part of it is, you know, what we're doing at Frost to capitalize on this, what we think is a massive opportunity. So, you know, it's kind of funny going last with this panel. I don't think there's anything I can say that's going to be an original thought, at least part of the presentation. But at the end of the day, you know, my focus is going to be on machine-generated data. So if you think about what IDC and other analysts are talking about, they're saying by 2020, 42% of the world's data will be machine-generated. I mean, to me, that's you know, that's astounding. And when you think about it, what's happening in real life is that over the last 20 years, organizations have invested in sensors, whether it's because it's been manufactured into these assets or they're making standalone acquisitions of these sensors so that they can derive the value of what that time series data means. That's been happening for 20 years. The problem is that those organizations have yet to see any benefit or very little benefit from what that time series and sensor data really means to making critical business decisions. And when I look at this slide, I mean, this is a slide that, you know, we kind of co-developed with GE. On one hand, you've got all of this data, tons of data. You've got trillions of devices. And then at the bottom of it, you've got CIOs, executives, and really end users counting on making sense of what this data means in order to really steer their companies, the divisions of their businesses, or really their own performance in a very productive way. So, you know, we really capitalize on that area. And when I think about the gap in this marketplace, I guess I better stay close if I haven't turned this on. I really think about the gap is where we at Frost Data Capital are focused on standing up companies, collaborating with GE and other strategic partners, Chevron, EMC and others, Cisco, where we can really begin to close that gap. So again, if you think about it, whether you're an oil rig, an ESP, whether you're a wind turbine, whether you're a jet engine, you know, all of these assets have been instrumented with sensors. And when you think about this kind of industrial data loop, I mean, this is a real, it's interesting. I mean, a 115B, a GE 115B jet engine on a 10-hour flight to Asia generates about 600 terabytes of data. And if you put that in perspective in terms of amounts of paper, it's 500 million pieces of paper that would get printed to support all that data. It's incredible. And what's happening is that the gap really shows up in terms of that industrial data systems component there to the right. But as that information is now being ingested into these what we're calling OT systems or operational technology systems, we're now being able to make better insights and better decisions from that data because we're able to visualize that data. We're able to push that data out remotely to people that can make decisions and machines that can make decisions. In fact, what we'll see is that in the physical systems intelligence world, machines will be communicating with machines and pushing that intelligent data back to those machines so that they can drive outcomes and financial results that impact the bottom line of the businesses that they represent. So whether that in a jet engine is fuel efficiency, whether it's pattern recognition on a flight path, whether it's turnaround time once it lands so that it can make all the appropriate mechanical changes, not just when it lands, it goes through the diagnostics. It's been going through the diagnostics its entire trip. So when that plane lands, it knows exactly what needs to happen. The people on the ground do. There's parts and equipment that they can source from the supply chain. So now all of a sudden this loop is far more efficient. And what we'll see over time from an IoT perspective is that this loop that has taken maybe weeks or months or even longer is going to be days and hours and minutes. So this loop is going to begin to move a lot quicker. So we've seen all the data. I was trying to think, is there anything funny I could actually say? And I was told that I'm actually not very funny, so don't try to be funny about it. But it's just, we've heard it all today. The number here that matters, and this is GE, is the one on the last one, the $20 billion of annual cost savings. That's one company in 1 year realizing $20 billion of savings. And the part of that number that doesn't jump off this slide that I think is remarkable is that a majority of that, and they didn't pass along exactly what percentage, but a majority of that is going to be from big data analytics that are able to ingest that machine-generated data in a way that allows them from whether it's brilliant factories, whether it's their jet engines, whether it's their oil and gas business, they're going to be more efficient and more effective. So the areas where we're aligned with GE, oil and gas, power and water, aviation, and these are areas that have really multiple $100 billion a year total addressable market opportunities. I'm going to share one with you quickly. I don't know where my time card is, but I'm going to share one with you quickly called Osprey Data. So what we've started and what our partnership with GE is, we went through a very rigorous dance with GE, and what we've announced last, I believe, April, is that we are the incubator for the industrial internet. Without going into detail, I've got 3 minutes left. It's an incredible accomplishment for this incubator here in Orange County that's now really responsible for standing up very quickly these companies that are addressing the industrial internet challenge across all of those industrial sectors I just mentioned. How do we do it? We ideate really at the ground floor. So we have ideation sessions with the CEO and CTOs and the engineers within each of those business units. So we're not thinking up technologies trying to chase a problem. We're talking to the customers. We're talking to the people that own the P&L and the revenue, and we're talking to their customers. And we're finding out, and it's a dance, we're finding out where are the big opportunities. We fund that, they fund it. GE funds it, we fund it. We then hire a CEO and a CTO. We make sure that they validate the minimum viable segment, minimum viable product, and there's a high-risk hypotheses process they go through. We have a rigorous process. We've got some world-class. I just hired the head of IoT from Accenture to be the CEO of one of our newest companies called Exara. So we're hiring some really top talent. And then on the second round of seed, we have strategic partners like Chevron coming in on that second seed to really say, you know what, we're excited. We want to co-invest alongside you and GE. So Osprey Data, it's a company I founded early on at Frost about 1.5 years ago. Bottom line is the old traditional ways of data modeling was you use companies where I used to come from, SAS or SPSS, and you'll go and you require data scientists. Well, what we've done, and I heard one of the panelists talk about it today, we've reinvented a way of putting the engineer close to the problem. So if you think about the Deepwater Horizon problem, the problem was that was a mechanical failure. That had they been able to forecast when that mechanical failure would happen, they could have had some planned maintenance and downtime to address that problem. So what we've done is we removed the data science component of it. And we've come up with this platform called Human Augmented Machine Learning. So the people who own the problem can actually type in natural language, I want to see all the assets that require turn curve analysis or tornado techniques, whatever it may be. They can then publish those models, annotate on those models, redefine those models. So now we've moved from kind of threshold alerts to real, true, intelligent modeling that can get published in near real time to multiple models. So as an example, Chevron has about 78,000 wells. They want to be able to analyze about 30,000 of those wells, and they want to repurpose models on a weekly basis. They can now do that with Osprey Data. So we've got 2 funds. We have a strategic partnership with GE, and we've got 22 portfolio companies under management. We don't take outside business plans. So what we do internally is we really find the areas of opportunity with these strategic partners, and then once we feel like we've got something that the investment committees at both GE and ourselves feel very comfortable about, we seed that, and then we find the appropriate CEO and CTO combination that can help us execute on those companies. It's interesting. We've got some very big names that are knocking at the door asking us if they could replicate what we've done with GE. And so there's nothing I can announce tonight, but we certainly are in conversations to bring some of those big companies, industrial companies, companies that are really trying to move into this IoT space very aggressively, to think about Frost Data Capital as a way to really close the gap from an off-balance sheet point of view, start really innovating and driving new companies and technologies, and then really from an intentional M&A point of view, this is a way for them to fund and seed these companies from its onset and then make the acquisitions shortly thereafter. So I love the comment about the buckets. We're banking on the buckets. We think there's going to be lots of buckets, and we're going to stand up about 50 to 75 companies over the next 3 to 5 years. So with that, again, we think we're really privileged to be in this big data and analytics space as the whole IoT market really gets not only on its feet. I had a conversation with the CEO of Accenture last week, and his comment to me was, Miles, I'm standing up a brand. He goes, since you took the guy away from me who I was going to have run it, I'm putting the whole organization around IoT, and I really think we're in the first inning. So, I mean, there is a lot of promise, and I think as we think about how we can stand some of these new ideas and new companies up, I think it's going to be an exciting future. Thanks for having me.
Thanks a bunch, Miles. Everybody, please give another warm round of applause for all the speakers tonight. And now I'll invite all the speakers to come up to the front table. And while the speakers are moving up to the front, you all might want to stand up and take a 7th inning stretch. We have gotten complaints in the past about how hard it is to stay seated for this long. But as I mentioned before, what I'd like you to do is go ahead and raise your hand if you have a question, and I'll move over to you with the microphone. And as our speakers answer questions, you can raise your hand and just get my eye, and I'll come over to you. Oh yeah, everyone has to turn their mic back on. All right, so does anyone have a question? Oh, there we go.
Hello, thank you, gentlemen, for great presentations. A lot of information. Being here at a higher education facility, my question is, what are some IoT implications for universities, schools? It seems like maybe we're talking industrial and we're talking technological, but how do we bring that to the universities to make learning more efficient or less expensive and things like that? Just curious your thoughts.
Well, maybe let me try to answer that. So I think in my presentation I mentioned about this open devices, and I think that's actually, well, we talk about a lot from the markets, dollar sign, money here, but I think one key thing in the IoT is really this, these low-cost devices and open. So open, of course, I mean, that's like even Broadcom has this Wicked platform, $20. You can buy that out there. Open not in the sense of like GPL and it's completely free, but it's open that as long as you sign the agreement with the company. Not just Broadcom, I mean, besides Broadcom, other company also do that. There are also two completely open source hardware platforms, so Raspberry Pi and Arduino. These are two examples. So these things I think is really lower the cost device, low cost devices, and in the education side, really, as I said, you don't need to break your bank to buy these things. And these are now these days, these are very powerful computers. Basically, it has some of it has 1 gigahertz dual ARM processors and with enough memory, maybe 512 megabytes memory, and the size is very small. It's like a cigarette pack, and first of all, it's affordability. Then the next thing for the university, these days a lot of alliances. Some is sponsored by the companies. A lot of Hackfest and hackathon. So in terms of educating people, I mean, not just for entrepreneur, people trying to set up a company in a garage, but I will encourage students to also look at that, and maybe they can join some of these hackathons and play with it.
Just add a quick comment, since I'm an educator myself. There are 3 things universities need to do to stay relevant, because this is going to move so fast that we're going to fall behind and be irrelevant, and we can be relevant, okay? So the first thing is, our primary mission is to train students, and we need to train our students so they're ready for this kind of workforce. That means focusing our experiences so that the students can get into IoT at any level of this food chain, whether we're talking about devices, as we heard, Raspberry Pis and so forth, big data, market, and so forth. So that's the first thing we need to do. The second thing we need to do is we need to direct our research so that it can be fed into this market. It's one of the biggest, fastest moving markets, and if we don't direct our research towards it, we're going to be left behind. And we have great research at the university. We can really contribute. So that means we need to turn our attention towards industrial partnerships, finding out what the needs of the market really are, and how can we apply our research into that direction. And the third is somebody needs to study this, and it's moving too fast for industry to study it. We need to understand what are the implications, what are the big questions that need to be answered, and the university is great for that. We're trained to think, right? So we should be doing that. We should be thinking, what are the implications to this as a society, to culture, to the future of our nation. And so those are 3 things that we need to be doing. We need to get on it now, and we need to not be shy about it. So.
Yeah, I like that idea. I think the other part of it is really practical application, right? I mean, there's one thing to have the academia and the textbook approach to what you're learning and how you stay ahead of that curve. I think the other thing is, we're ideating at Frost Data Capital probably about 6 to 10 companies per week, whether it's aviation, whether it's manufacturing. It's very specific. One of the things we're thinking about and talking about is how do we bring students out of the university to come in and do internships, form SWAT teams, because when we sit down and do this analysis with GE, they bring a room like this. It's incredible. So we're completely outmanned, but it would be incredible to partner with the university to bring some of the young talent that's studying here into a real-life internship approach. That to me would be invaluable.
I think repeating what you just said, the example that Khalid and the plug load is setting is really the best thing that could happen for industry, and in terms of the best way university can help and take care of the implications of IoT is by really getting immersed in the reality of industry, right? By helping industry, by helping small companies, by not thinking that all the answers are in the research, as you say, they're not. And so we can provide that dose of reality, and we feel really good about being able to join Khalid too, and CalPlug in particular. So more of that is really going to go a long way.
Yeah, another thing I'll add is that, I just was on another panel just recently, and fortunately, I think the whole topic of certainly like big data, data sciences is now something that's very relevant, right, to industry. I mean, this is one of the few topics I found that resonates very well. And I think there's a very strong opportunity for the universities to now really collaborate with industry and trying to find solutions, and more importantly, people, right, who can deal with the scale of data that's coming out. It's a different world, right? You've got now large companies, who are hiring software engineers. That wasn't true in the past, at least not as true as it. So I think the good news is that because, I think industry is now kind of realizing that, we need to stay ahead in technology because of this big movement. They are going to look towards the universities, and universities, as far as I can see, certainly UCI has been responding.
Yeah, I agree with all of the above. I would just add, I think there are a lot of ways as well that technology itself can continue to make education an even richer and more effective process. We're very interested in the implications of wearables right now. And when you combine them with things like augmented reality, the ability to interact with things and to understand the world that we live in, whatever subject matter it is going to be a tremendous accelerator of learning, we believe. Plus all of the devices that we have and the ability to prototype things rapidly, I think we're going to see problem solving and approaches to that really changing. So all of these different approaches to educating and making students, really the skills required to be successful are going to be very, very different. But the IOE or IoT itself is providing the tools and technologies to help foster those skills.
I just have to say that was one of the best panel responses to a question I've ever seen. All 6 of you responded, and they were all well thought out. Sorry, go ahead.
My name is Yoshinoguchi. I have a question. IoT market will grow faster if things can truly talk to each other. And then looking at the B2C side, these 5 guys put together this industrial internet consortium to come up with a standard. And on the B2C side, particularly starting with Home Network, Google's Nest and the Thread Group, Apple's HomeKit, and Intel and Samsung's Interconnectivity Consortium, and then now all seen with Microsoft and the Qualcomm. So like all these major players are gathering together, basically sort of like a survivor, creating alliances, but they don't talk to each other. So how do you think all these sort of a standard bodies are going to play out so that the IoT can actually become reality and then the things can actually talk to each other?
I have a thought that I have a term for the European Union. I call it the European Disunion. They try to get together, have some currency. It's been successful to a certain point. I think the point is that everybody there, every country has a different language, different customs, but yet they work as a community. And we could argue that they don't cooperate as much as they do, but they're still a huge powerhouse worldwide. And obviously, I think the standards tend to stifle things, and to hope for standards when you have the Cisco's and the Intels and the Broadcoms, I think you're dreaming. Everybody's going to have their own variation, and maybe we should embrace that as being healthy. We've made it a point to make translators, if you will, of things and abstracting. So disparate protocols, putting them to a common language, disparate devices, taking sensors, talking or getting data to something else that may be miles away, speaking a different language. It's an opportunity, and it's the reality what we're going to have to live with. And we should not look at that as a detriment or as something that will slow us down.
There won't be like a Esperanto type one.
No, I don't think so.
There will be multiple languages, multiple basic standards, and there'll be translators translating in between.
I think the closest thing that we're going to get to anytime soon is having so-called RESTful APIs, where there's at least a commonality of how to get packets out there. But the contents, what's there, and what they're going to do on each device will continue to be different.
Yeah, and I think one of the things that you're seeing, probably not talked about as much, is I think we've grown up on the IT side of the world used to a common set of operating systems and protocols. On the OT side and the operational technology side, I mean, look at what happened last year with one of the large EMP companies where there was a malware intrusion. It came into the SCADA system. It moved the drill location off by about a quarter of a mile. They didn't know for 9 months. So it's an incredible, sad story, and they spent tens of millions of dollars just trying to remediate that. The perimeter's disappearing. So I think the reality is, back to I think a lot of some of the thematic aspects of what we talked about, you're going to see a lot of opportunity for companies to fill that gap, to innovate around starting companies that can help address some of those problems.
Actually, I think you miss another big standard being developed right now. That's called 1M2M. So that's more, driven by the telco companies. And it's actually a good start because it's actually 1M2M is formed from 7 regional standards body. So the US, North America, SC, Europe, and China, Japan, and Korea. So finally, these different regional bodies are willing to sit together. So coming back, I think, at least myself, from what I see, right now, yes, there are a lot of different standards or consortium, and some are kind of complementing each other. So they are trying to solve different problems, like say all-SYN and 1M2M actually are not really conflicting with each other. But say ZigBee and Thread are competing with each other, right? If Thread is successful, then it actually can replace ZigBee. But what I see is that the industry now, I see there are, some of the organizations start to work together, and I would expect that this trend will probably go further. For example, recently I find out actually all-SYN and 1M2M are working together. So that's trying to get some kind of interworking function between the proximity network and the cloud created by the 1M2M. So I'm expecting to see more. At the end of the day, you can, as I say, as this IoT market continue. Of course, the market, the big guys like Apple and Google probably try to dictate certain things, but now this market is so big that they may not be able to control everything themselves. So, and I would, I expect to see more collaboration between different industries.
Yeah, let me add, that I've been around for a while, admittedly, and I've seen the days of Corba where all these standards that actually failed, but I'm pretty optimistic about XML, all the recent standards. I mean, they're human readable, at least they're supposed to be. They're all meant for interoperation, and we've been doing this for a long time now. Yeah, nothing's going to be perfect from that standpoint, but at the very least, it's the chances of success, I think, for integrating and interoperation are much, much higher than they were in the past. The other point I want to tie back to an earlier question was about, the role of the university. I mean, of course, I'm a little bit biased, but certainly I think the university and standards group should go hand in hand. If anybody's going to look like an impartial body, right, academics certainly has a very good role to play in that, and hopefully that continues.
Yeah, I agree. I think we will always see the innovation of new standards. Each one attempts to do better than standards that have come before, and they all have their pros and cons. So we always try to encourage standards bodies, and we obviously participate in a lot ourselves, to think about at least interoperability or to foster interoperability through some of the common gateways or hubs. We saw a lot of these devices as well that can speak those different protocols, and then let the users and the creators of those solutions choose the protocols that are best for their business application, and to have some underlying. There are many different layers in the communication stack, from the human readable XML or JSON, et cetera, right down to the physical layers and so forth that have their strengths in terms of power usage and distance over which they're reliable and things like that. So as long as there are some common foundations, and in particular the internet protocol at the very foundational layer, we think has driven a lot. So we may see some convergence along those lines in the IoT in the future, but we believe in the evolutionary selection of the best technologies over time, and just to make them interoperable.
Yeah. My question, I think, goes back to a couple of the points that Mark raised in the first place in terms of major areas for the IoT. One of them being, one of the major opportunities being in energy and resources and so forth. One of the major weaknesses, vulnerabilities, being security. And it strikes me, from what I've seen and from some of the things I've read, that there's a bit of a war going on right now between the bad guys and the good guys in terms of security. It's sort of the good news about that is that it's mostly fought over the question of money. Somebody moving, making $50 billion or whatever they make out of a scam, all right? And that's one thing, and as long as the system as a whole generates more cash flow than it loses due to insecurity, you can argue that society is better off for the system as a whole and should go ahead with all of the creativity that we're talking about. But the problem, it seems to me, that with the creativity is that if it isn't controlled or managed at certain points appropriately, that the security starts lacking because you get the possible vulnerabilities may increase exponentially as the system increases exponentially, right? So your security problems are going to get entirely out of hand if you don't start thinking about that. And in a situation like the energy industry, where the solution to a lot of the problems is, for example, a smart grid, which has the entire country running off of a particular approach to the grid, if you have those kinds of vulnerabilities in your energy system and somebody on the outside seeks to just plain do you harm by shutting down the country, for example, is there somebody, what are people thinking and looking at doing in terms of, at least in the energy industry or other places in the world, where it's our vulnerabilities are more than just monetary? What are we doing about security to make sure that we can stay ahead of the bad guys, if you will?
I mean, I'm happy to talk about it because.
Go ahead, yeah.
Sure. So we're in the middle of you know, GE just acquired a company called Theta Ray. They've also got another piece of their operational technology group called WorldTech. And you know, we're literally thinking about this as we speak. We had a call today where the head of security from Cisco, John Stewart, had participated with us on this discussion. And you're right. I mean, as you think about the number of devices that we all talked about are being exposed to the internet, therein lies your vulnerabilities. And the question of you know, endpoint security relative to malicious attacks, those are happening as we speak. There's, you know, the comments that were made is there's no need to hold up a bank anymore because I can make far more money hacking into accounts under an alias and taking as much money as I want. And the sad part about security is, number one, there's no ROI, right? So when we talk to the security division at GE, at Cisco, and others, there's not a real ROI, but boards are all talking about it. In fact, the feedback to me from some of the big corporates are, we need solutions and we need them now. Oil and gas companies, utilities, locomotives. I mean, one locomotive was just hacked. So, you know, locomotives for GE is a big deal. That operational system was taken over, and that was kind of like a movie scene. That locomotive apparently was running on its own with someone else from the outside controlling its outcome. Absolutely. It's very concerning, and it's very scary. And the IT technologies that we all know from Symantec, those technologies don't solve the OT problem, right? So as we think about it, we're thinking about it every single day. We've started one company today that's talking about endpoint security, but that's just a small portion. I mean, that's just anomaly detection at the perimeter that's detecting, you know, bad behavior. But it is a risk, and it's something that I think as a panel, the big companies, I think everybody's going to have to work together to really fight this because it's a problem.
Mhm.
Best comment. I think that this discussion, this attention, is between having all the creativity such that nobody can understand what all the potential vulnerabilities are out there because you have no idea what.
Well, but companies aren't talking about it. It's almost like it's almost like a crime that you don't want to share with someone that you committed or that was committed on you. So it's not, a lot of it. There's new disclosures and there's new requirements coming out that are going to talk about some of that disclosure. The one I shared with you, I didn't give you the name, was confidential. That was never disclosed, and that impact was scary, right? And to your point on the utilities, there's a number of attacks on major utilities of shutting down the grid that you know are happening daily.
only have time for. So let's just work. We'll just move on to the next question right here.
I'm Charles Kim, Southern Cal Edison Company. Underlying assumption of Internet of Things is being connected. People or devices is connected because they want to be connected to a certain thing that has a value to the people, but not everyone has the same value. So I like Professor Bachman's comment. We know Internet of Things is coming. It's a big, $7 trillion to $17 trillion, but we don't know where to put the bucket. So we have a smart panel here, and I just want to pick your brain. I know the medical devices will be connected in the near future, amazingly, because it has an inherent value to the many people. That's commonality. My question to the panel is, where and how you analyze the value to the market assessment, how many people want to be connected, strongly connected to that value, and where you put your bucket to collect the money.
Well, I think, let me just start off, because I know everyone's probably got an opinion on this. And I think we're seeing a lot of movement into infrastructure monitoring, industrial monitoring. So we're talking about putting sensors in industry, in buildings, and so forth for energy management, smart homes, and so forth. So that's kind of the early horse out of the gate, so to speak. I was going to respond to your question, but you got such a better answer there. But the actual security is a huge growing opportunity. The first questions that people ask me when I talk about IoT, absolute first two are privacy and security. So everyone gets it. Everyone gets that's a problem. We don't know how to solve it. But those are opportunities. And so we just heard about an acquisition of a company right now, for example. So I would also look to security as another opportunity if you're thinking about starting a company or investing in one. So, but further down the road, I think these, especially on the cloud side, where we actually, right now we're putting sensors and things, we're putting Nest thermostats in, but we're not really using that data. And so I see beyond instrumenting buildings and instrumenting factories, what to do with that data, and that's really another opportunity. But I'm sure there's billions of opportunities you guys can come out with too.
Well, let me put my thought there. So I think I used iPhone as an example. So I think actually, definitely I didn't work in Apple, so I don't know what Steve Jobs thought about, what kind of ROI analysis in his marketing department when he come up with the iPhone, because just from public information back in I think 2007 when the iPhone first come out, there's a Nair from Motorola, Nair from Nokia, and a lot of so-called technology analysts at that time say, not going anywhere. So you see who's still standing and who pretty much go out of business. So I think I would not get into the business of predicting the future. I cannot do that. And one thing I think come back to one strategy that Broadcom is doing is because we really don't know who will be the next big guy. We don't. We know who are our existing big customer, and of course we dedicate our resources to help all our existing big customers. But like GoPro, a few years ago, no one knew GoPro can be that big, right? Actually, they contacted Broadcom. But anyway, so that's why we have this wicked strategy, and basically we have this device and let people to develop things, open it up, and people can develop this, because we really don't know who will be the big guy next. And and Broadcom strategy is less, because we don't have enough resources to address every single body, and we don't know what the of course we have our idea, but there are many people out there. They have very nice ideas, and we just enable them to do it. And at the end of the day, of course, then that will benefit the company. We can sell more silicon.
Yeah, I've got so many ideas. I mean, I was just driving along, some guy holding up a stop sign, and all these signs. Do we really need these things with IoT? I mean, I think can't patent that now, huh? So you can't. There are tons and tons of opportunities. I think that's just going to be amazing. I'm just so excited. I do want to comment about the security question, because I mean, this is that brings back nightmares of IT guys, trying to lock down systems and, not enabling, things and becoming more of a problem, than a solution, and hey, the PlayStation Network came to life. They didn't think about security. Still useful. So in other words, I think there's going to be a huge business in security. I guess in my experience, it's always been kind of more of a policing, anti-innovation to some extent. Hopefully people find more sensible solutions around these things and not be chicken about doing something that's truly innovative.
Yeah, personally, I wouldn't be able to offer any one particular area to go and buy stock in, for example, but I kind of like to use a model, and not to be tried, but I do think that necessity is the mother of invention. So we like to look for the problems out there that people keep bringing up, the things we hear from customer after customer. This is a common theme and a problem where there's something physical, some physical aspect to it. So the digital revolution can't quite solve it, but if we go into the IoT, we can shed new light on it. And then also, I think there's the barrier to entry bit as well. If it's a hard problem that's been around for a while, then the first to solve it, and of course to capture the value and protect the intellectual property and so forth, will drive a lot of value from that, and will be very valuable as well. So maybe something like a 2x2 in terms of the value of solving the problem and the ease of solving it would be a good framework to sort of think about these opportunities.
I work with some very large companies, and one thing I can say for certain is that the major things that we've seen over the past 100 years that have changed the economy around did not come from those corporate strategic sessions or business planning meetings. So that's a very difficult question to answer in terms of where do you see things happening. We really don't know. There's a lot of buckets out there, and or a lot of places to put the buckets, but it's going to take that eureka moment. And I think probably from an investment viewpoint, you probably see this all the time, is when you see the opportunity, somebody is why didn't I think of that before? It's like it's so different. So I'll leave it at that.
Yeah, we just have time for one more question, so go ahead.
Coming out here, oh, there we go. Yeah. Thank you very much for coming out here today. I'm an aerospace graduate student here at UCI Aerospace Mechanical, and I spent the first 6 months of this year working with the Entrepreneur Center doing an IoT startup. So this is very relevant. I probably could sit here and ask a dozen questions, but I'll try and focus on one. The issues come up about standards, and one of the issues that we found was finding a development kit was difficult, but also a question around reliability was a problem too, and it seems like these issues are going to be very much related, because if you have a lot of desperate standards, it looks like there's 24 more dozens of standards out there now. It's going to make it difficult to take advantage of some of those healthcare applications, because that's where reliability is very important. And on that side of it too, would you guys recommend a particular development environment, or would you recommend maybe finding an enterprising group of software, hardware people that are doing maybe their masters and just sort of hacking away on our own? And then how does this sort of, like space, how does it differ from previous, say, format wars, like when Google was fighting over the internet and they ended up becoming the king of search, or DVD, Blu-ray, those kinds of things? How is this space kind of different from that situation?
Well, maybe I'll start. You mentioned search, actually, and I think that's a big area of need. I'm a big believer in the wisdom of the crowd and in open collaboration across large groups. So you probably will find it more efficient to focus on ideas and incubate them in a smaller group, but very soon I think you'll find a lot of value in bringing in more ideas from outside and so forth. I couldn't particularly recommend any platform. You could probably get a lot of opinions from the panel as well. But one thing I think we do need is a better way to search for what already exists, because we're in the very early stages. The first inning, I think, was a good way to describe it. And we're seeing the building blocks of the IoT created over time, and then those are reusable. So every time someone invents something, it's basically problem solved and done, right? We should never be reinventing the wheel, and yet I bet if we could really do the research and know, it's happening all too frequently. But it's still hard. I mean, as good as search for facts and things and semantics are coming into play is, it's still hard to find solutions to the particular problem that you have or to know what are the best building blocks. So I would encourage all of us to think about ways we can improve sort of directories of these reusable components and what's needed to accelerate in that respect. But I would say open innovation and keeping your eyes open for new possibilities.
Yeah, one of the things that made security much more secure is open source. You know, if you go to talk to the security, it was Bruce Schneiderman or whatever, right? It says that definitely, having the security protocol being inspected and reviewed by everybody, right? Sure, you might know some weaknesses now, but at the same time, having that crowdsourced peer review, right, can really improve things and build confidence in things, right? There's a lot more knowledge base now on the TAC mic. That said, I mean, there are just some hard problems, right? And when we talk about reliability, I mean, the bigger threat is just going to be, just some implementation error, right? Some architecture errors. And unfortunately, I mean, those are just going to have to be solved by somebody who's experienced and can really look at the problem and then recommend the right system. I mean, I had this one other guy I talked to. He's working at Care Fusion. He literally makes software for heart monitors and things like that. Formal methods. I haven't heard of that in like decades, but they're using it. It's a very expensive way to do it. But hey, if it's that important, then there are actually tools out there to help get that reliability, that you're looking for. But yeah, it all comes at a cost. Security, reliability, there's a price.
That's about all the time we have. So thank you, panel, and everyone, please show your appreciation. Please enjoy dinner outside, and the bar is open.
Mas, I really enjoyed.
Yeah, nice meeting you.
Turn this off.